My name is Mark Profit, and I'm the author of Predictive Innovation. Predictive Innovation is a revolutionary way of thinking. It shows you how to find all of the ideas for a topic. Not just more or better, but all of the relevant ideas. That allows you to choose the best idea for you. Everyone from young children to senior citizens can benefit from using the principles of predictive innovation. That's why I made this video. I want everyone in the world to learn and use it to make scientific discoveries, solve seemingly impossible problems, and change the world for the better. Predictive innovation is a complete system of thinking, but you don't need all of it to start getting huge benefits. The alternatives grid is the central tool of predictive innovation. It applies to everything. Anything that can be made or done is described using the alternatives grid. This video explains the logical basis of the alternatives grid and shows why it is the core of describing anything that can be made or done. The alternatives grid stems directly from the discovery made by two geniuses who changed the world. The work of Kurt Gödel and Alan Turing proved that a complete system for representing information can be created using simple comparisons. Simple comparison is the foundation of modern computers. It's why we say computers use ones and zeros. All information can be represented with a series of ones and zeros, true or false, same or different. When you compare any two things, they are either the same, such as these triangles are the same size, shape, and color, or they can be different. There are two fundamental ways something can be different. It can be a different type, such as a triangle is a different type of shape from a circle. These two triangles are different colors. Color is a type. The other fundamental difference is amount. The triangle on the left is the same shape, color, and size as the triangles on the right. The number of items or count is different. There are more triangles on the right. The number of items or count is an amount. The shape, color, and count is the same for these triangles, but the size is different. The size is less. Size is an amount. So when we compare things, we say they are equal when they are both the same type and the same amount. The first way things can be different is a different type. That's not equal. If something is the same type, the amount can be different. Amounts can either be more or less. These are the basic results of comparison, but there are two more. If you combine less and same, you get less sameness or change. Something that fluctuates is less same than something that never changes. If a part of something is the same type, but another part is different, then it is less same than something that is identical. If you combine same and more, you get more sameness. This can also be thought of as stabilize. That's why we use the arrow for this symbol. More sameness is approaching the amount or becoming more similar. Putting all of these together, we have the 6 directions of the alternatives grid. These apply to anything. They describe types of ways things can be the same or different. When describing nouns, we use these types of descriptions: same, more, less, different type, change, or close. Some other ways to think of the 6 directions are keep, direct, indirect, opposite, indirect, other, fluctuate, repair, restore, stabilize, or towards. These tend to be better for describing verbs or actions. Those are the 6 directions of the alternatives grid. The other side of the alternatives is scales. Directions deal with what things are and the way they change. Scales deal with measuring. The first measurement is existence. Does it exist? Is it true? One or single is the starting point. When there's only one, it is unique. The next scale follows from single. 0 represents none or never. Something doesn't exist. The other extreme is all, every, always. It is beyond measure. Between 1 and 0 is partial. Partial is fundamentally different from either 1 or 0. It doesn't quite exist as a complete unit because something is missing, but it isn't nothing either. And partial is a range. It's not just one point, like single, one, and all. And between one and all is many. Many isn't just more than one, it's a different type. Many isn't just one amount, it's a range of amounts. It is also many. Amounts like 2, 10, or 1,000,000 are essentially the same, but all is fundamentally different. Many is a different type than one, none, and all. Many and partial are related because they cover a range of amounts. Finally, each point between none and all is any. Any, all, and none are similar because they all describe a different type of unlimited or continuous. This is the complete set of the 6 scales. 1, partial, many, any, all, none. The 6 scales are the other side of the alternatives grid. If you've seen my other videos, you may have noticed I say there are 15 alternatives, but this grid shows 36. The 6 scales and 6 directions share relationships. The directions same, stabilize, and change are related by sameness. The indirect directions, less and other, are related by being different from the direct or more alternative. The 6 scales can be grouped together. The single scale is unique. It's a type by itself. Partial and many are related. Partial and many are ranges of amounts of the same type. They are parts of a single whole, or sum of all, so we can group them together as multiple. All, any, and none are different types of unlimited or continuous. All is unlimited amount. Any is unlimited type. None is unlimited in not existing, no amount of the specified type. So any, all, and none can be grouped together as continuous. The not equal sign is used to mean other. Other means a different type. So there's another complete grid of alternatives for each other type. After grouping the alternatives, we have 15. There are always at least 15 alternatives for anything. And, as I just demonstrated, there are often many more. So this shows you the alternatives grid, the core principle of predictive innovation. It shows you how to find all of the ideas for a topic. Not just more or better, but all of the relevant ideas. That allows you to make scientific discoveries, solve seemingly impossible problems, and change the world for the better.